In this video, we're going to look at dividing polynomials. We're going to use long and synthetic division to divide polynomials. So we're going to start with a couple of warm-ups. With your partner, answer the following questions. Find a polynomial whose given the information below, and sketch the graph of the polynomial. I have an intercept at 0, 9, and it doesn't tell me which one it is, but since I know that the x position is 0 and the y position is -9, that must be my y-intercept. Okay, so since I have to sketch it anyways, I might as well put that on there. 0, -9, not drawn to scale. And my degree of the polynomial is 5. X is equal to 3. X is equal to 3 with a multiplicity of 2. So that tells me my factor would be x minus 3 of a degree 2. So I'm going to go over here to positive 3. So this is 3. X is equal to 1 with a multiplicity of 2. So if x is equal to 1, and it's a multiplicity of 2, that means x minus 1 of a degree 2. So I'm going to go over here and I'm going to put down 1. Again, not drawn to scale. And x is equal to -1. So x is equal to -1. That tells me my factor must have been x plus 1 with a multiplicity of 1. So that's going to go right there. There's 1. There's -1. Here's y and here's x. It tells me as x goes to -infinity, my function goes up, and as x goes to positive infinity, my function goes down. So I know with multiplicities of 2 that I will bounce. Multiplicity is 1, I pass. So I'm going to come down here, and -1 had a multiplicity of 1, so I'll pass through it, go through that intercept, go and touch that -1 or positive 1, excuse me, and bounce. Come down, I don't know how far. Come up to 3, touch, and then bounce back down, and there is my function. There's a picture of it anyways. Now, we know from before what we need to do is we need to take this information and use this intercept to figure out what a is. So I know my function f of x is going to be some constant or some coefficient a, x minus 3 squared, x minus 1 squared, and x plus 1. Now I'm going to use the fact that when I put in 0 for x, -9 comes out. So -9 is the answer. A, 0 minus 3 squared, 0 minus 1 squared, and 0 plus 1. So I have -9. This will produce a positive 9. This will produce a positive 1, and this will produce a 1. So I have 9 multiplied by 1 multiplied by 1, which is 9a. That means a equals -1. So that means I can go back here and write this as a -1. So I'd rewrite this as f of x is equal to -1 multiplied by x minus 3 squared, x minus 1 squared, and x plus 1. Now, without using a calculator, we're going to find the quotient and the remainder. So if I'm asked to do 347 divided by 21, I would do 21 out here. I would write the division symbol and 347. Then I'd ask myself, how many times does 21 go into 340? I'm going to ignore the 7 for the minute. And I know it's going to go in there at least 10 times. So I do the 1 multiplied by the 1 and the 1 multiplied by the 2. And so I get 210. Remember, this is in the tens position, so I put a 1 in the tens position. I don't have to have that 0 there if you don't want to. If you're like, I don't remember ever doing that. Okay, cool. You don't have to have that 0 there. But this is the division algorithm, and so we would do the subtraction. We get a 3 and a 1 and a 7. We get 137. And then we ask ourselves, how many times does 21 go into 137 without going over? So I think maybe 5, 6. Let's try 6. So 6. 6 multiplied by 1, which is 6. 6 multiplied by 2, which is 12. I do this subtraction and I get 11. So my remainder is 11. Now, you probably did this in grade school, middle school, and you would have said 16 remainder 11 or something similar to that, right? So another way you could have wrote this is you could have wrote this as 16 plus your remainder divided by your divisor, which is 21. Or if you would have used your calculator, you would have got a decimal equivalent. And so I'm going to just get my calculator out, and I'm going to do 347 divided by 21. And you would have gotten, if you used your calculator, 16.5238095 But that's not what we wanted to do. We wanted to do this without a calculator. And the reason is because we're going to use the same division algorithm when we do the division of polynomials. So whether it is in like this form or this form, the algorithm is the same. So let me do the second one. So I have 53 divided into 7,682. And really what I'm asking myself is how many times does 53 go into 7,600? So if 53 goes into 7,600 100 times. So I put a 1 above the 100's position. So this is 53, and I really do have 2 zeros there, but we typically don't write that when we're doing the division algorithm. So then I subtract off that 53 from the 76, 5,300 I should say from 7,600, but algorithm usually it's 53 from 76. This gives me a 3, this gives me a 2. I bring down the 8. So then what I'm asked to do is how many times does 53 go into 2,382, but we're really just looking at that 2,380 or 2,380, and we ignore the 2 for a moment. Now we could bring that 2 down. It's not wrong to, so we'll go ahead and bring that 2 down doing the division algorithm. And so we know that 40 times, if I multiply 40, because it's in the ones position, 40 times 500, or 40 multiplied by 53, will give me a number close to this without going over. So I'm going to do the 4 multiplied by the 3 and the 4 multiplied by the 5. Now remember, this is 40 multiplied by the 3, so that gives me a 2 right here. And then the 4 multiplied by the 3, or excuse me, the 4 multiplied by the 5 is 20. I had to carry that 1. So 2, 1, and then there's a 0 right there. So we do this subtraction. 2 comes down, we have the 6 that comes down, and then we have 3 minus 1, which is 2. So now I have 262. So I ask myself, how many times does 53 go into 262 without going over? And you're thinking, oh, it must be 5. So let's try that. 5 multiplied by 3, which is a 5. And then 5 multiplied by the 5, which is 25, plus we had to carry that 1. Oh, that's actually slightly too big. So it's not going to be 5. It's going to be 4. So here we go. We put a 4 right here, and we get 212. Do the subtraction, I get 50. So my answer is 144 with a remainder of 50. You might have seen that in grade school, or it's the same thing as 144 plus 50 divided by 53. Or if you use your calculator, which I didn't want you to do, I would have taken 7,682 divided by 53, and you would have had 144.94336962. Now I'm not going to do C because you're like, I know how to do the division algorithm. That's cool. What we're going to do now is the division algorithm with polynomials. So when we divide one polynomial by another, we're going to get a quotient and we're going to get a remainder. So if I come back up here, this is my quotient and this is my remainder. This is my quotient and this is my remainder. So when we're going to do it with polynomials, we will still get a quotient and we'll still get a remainder. If the remainder is 0, which it wasn't up here, but if the remainder was 0, that means that 53 is a factor of 7,682, which did not happen on these two cases, but if it did, that's what it means. Same thing happens with polynomials. if I do the division and divide one polynomial by another, if I get a remainder of 0, that means that it is a factor of that polynomial. So we have our dividend, we have our divisor, we have our quotient, we have our remainder. So the dividend is a polynomial we start with. The divisor is the one we're going to divide by. This will be a quotient, and we have some sort of remainder. So if I'm asked to do the long division algorithm, it is exactly like what we just did with our numbers. I'm going to take the x plus 3. That's my divisor. My dividend is 2x to the 4th plus 7x to the 3rd plus x minus 12. Now this is where it kind of deviates from the numeric values that you would have learned before. If I am missing any of my powers, I need a placeholder, so I need a 0x squared, and I need a plus x, and then minus 12. I didn't have an x squared in my original dividend, so I had to put in an x squared as a placeholder. I don't have to do that with numbers because you're not going to have numbers missing, and if you do, you have a 0 as a placeholder. So then we ask ourselves, how many times does x go into 2x to the 4th? Well, to go from 1 to 2 as a multiplication needs to be 2. Go from an x to an x to the 4th needs to be x to the 3rd. So I'm going to put an x to the 3rd right here, just like in my division algorithm above. Notice I'm going to stack under above like things. This is x to the 3rd, and that's what I need to multiply this x by to get to the 4th, and I also need a 2 here. So I would take 2x to the 3rd, multiply it by x. I will get this leading coefficient and this leading power. So I'm going to have 2x to the 3rd plus, and then I have to distribute it or multiply this also onto the 3, which gives me 6x to the 3rd. As before, I need to subtract off this polynomial. When I subtract off that polynomial, what that means is that my sign is going to change on both the 6x to the 3rd and the 2x to the 4th, and that should be x to the 4th. Let me get rid of that. That should be x to the 4th. X to the 4th. Okay. So when I subtract it, both of those signs change. And notice I just do the sign change up above the original sign, which happens to be plus 6. This gives me 0. This gives me just x to the 3rd. And then I bring down my 0x squared, just like up above. Now, I can bring down the x, and I can bring down the negative 12. That's totally fine to continue doing that. Just like in the division algorithm up above, we could have done that. In this case, I'm not going to right now, so I'm just going to bring down what I need to bring down, and I ask myself what I need to multiply x by to get an x to the 3rd. We know that is x squared. So I'm going to have plus x squared. So I'm going to multiply this x squared and this x squared and that 3. So I'm going to get x to the 3rd plus 3x squared. Now I'm going to subtract that off. My signs change. This goes to 0. This gives me negative 3x squared. My next term drop down is the x. So how do I get from x to negative 3x squared? I need to have a negative 3 and I need an additional x. So multiplying by negative 3x. When I multiply this negative 3x and this x, I'm going to get the negative 3x squared. When I multiply this negative 3x and this 3, I'm going to get a negative 9x. Now I'm going to change my sign. This becomes a plus. This becomes a plus. This goes away. That goes to 0. This becomes 10x, and then I bring down my 12, so minus 12. I ask myself, how do I get from x to 10x? And that is multiplying by a positive 10. So what I'm trying to do on this division algorithm is I'm trying to make the coefficient here and the coefficient here match so that when I do the subtraction, they cancel themselves out. And I need the powers to match. So the power on this, when I multiply it by something, needs to match the power on this. That's why this one only needs a positive 10. Now when I do this multiplication, I'm going to get a positive 10x. I'm going to get a positive 30. I'm going to change my sign. That goes to 0. I have negative 12 minus 30 more is minus 42. So my quotient is this. This is my quotient. My remainder is this. So plus negative 42 over my divisor, which is x plus 3. And that is my long division. Since I have a remainder here, that tells me that this is not a factor of this polynomial. Had this been 0 when I got totally done, then this x plus 3 was a factor of this polynomial. So you must use long division when dividing polynomials and the divisor is not linear. If it is not linear, you have to do long division. But if it is linear, there's an easier way, right? And the answer is yes, this is synthetic division. It's also called the collapsed version. So if I do the synthetic division, first thing I'm going to do is the opposite of this. So this would be x plus 3, so x is equal to negative 3. So I'm going to put negative 3 right here. Now with the collapsed version of the synthetic division, I need to have just the coefficients 2, 7, 0 for the x squared, 1, and negative 12. This is the coefficient on the fourth. This is a coefficient on the third. This is coefficient on x squared, which you know is 0, x, and then the constant. All right. So the first thing that happens in synthetic is this first number just drops down. So this number is just going to drop down, and it's going to give me 2. To do this, what goes right here, it's going to be this negative 3 multiplied by this 2, which gives me negative 6. And I'm going to add in this direction, so I get a positive 1. What's going to go right here is this negative 3, and this 1 is going to go right here, so that's negative 3. These add, which is going to give me negative 3. This negative 3 multiplied by this negative 3 is a positive 9. And I'm going to add straight down. This gives me 10. This negative 3 and this 10 gives me a negative 30. This little box is your remainder, which is negative 42. Now, I want you to notice when I did this synthetic division, in fact, I'm going to do it right next to here. I'm going to do it again, the synthetic division again. So I have negative 3, my x to the fourth term, my x to the third term, my x squared term, my x term, my constant. The coefficients are, from my original, is 2, 7, 0, 1, and negative 12. This drops down, so it just becomes 2. What goes here is the 2 multiplied by that negative 3, which is 6, and I add these together and I get 1. Notice this 2 is this 2. This 1 is this 1. Notice over here as well, the 6 and the 7, the 6 and the 7, well, negative 6 when you do the subtraction. Here we're always doing addition because I took care of the negative right there, and I get 1. I get 1. So as we continue on, what's going to go here, what's going to go up here is the negative 3 multiplied by the 1. I'm going to add straight down, so I get negative 3, which is this term right here, which is this term right here. So again, what's going to go here is the negative 3 multiplied by the negative 3, which is 9. I add down, and I'm going to get 10. 10, 10. And then what's going to go here is the negative 3 multiplied by 10. Here's my negative 3 multiplied by 10, this part. And my remainder when I got done was negative 42. Here's my polynomial. Here's my polynomial. This doesn't look like a polynomial. This obviously does. Once you've done synthetic division once, you drop a degree. So if this started with x to the fourth, then these are the coefficients for x cubed, x squared, x, and then the constant. So then this becomes 2x to the third plus x minus 3x plus 10 with a remainder of negative 42 over x plus 3. Here it is in all of its glory in long division. Here it is in synthetic. Now, the only time you get to do synthetic is if your divisor, x plus 3, is not a quadratic. So if this is x plus 3, you can totally do synthetic. If it is a quadratic or higher, you have to do long division. Okay, so you get to fill out the steps to do synthetic division here, whatever it is, however it is that it makes sense to you. So now I'm going to use synthetic division. I'm going to do these with synthetic division. 2 is going to go here. Notice it's the opposite of here. I have 1, negative 7, 13, and 3. My x cubed, my x squared, my x, my constant. 1 goes here, 2 goes here. That gives me negative 5. Negative 10 goes here. Those add together, giving me 3. 6 goes here. This gives me 9. So my quotient is x squared minus 5x plus 3. This is my quotient. My remainder is 9. That tells me that this polynomial is not a factor of this polynomial. Let's do the next one. So I'm going to use a positive 2 here. Opposite of that. 1, 0, negative 3, and 10. Because I have the x squared, or the x cubed, the x squared, which is missing in my original polynomial here. X and then my constant. 1 comes down. Those 2 multiply to give me 2. These add to 2. These 2 multiply to give me 4. These give me a positive 1. And I have 2. So it's 12. I have x squared plus 2x plus 1 is my quotient. My remainder is 12. Let's do this one. So I do the opposite, negative 2. X to the 5th. Well, this time, so I'm not going to lose places. I'm going to go ahead and do x to the 5th, x to the 4th, x to the 3rd, x squared, x, and then my constant, because there's a lot that are missing. So I need 1, and then a 0, 0, 0, 0, and 32. So the 1 drops, and I get negative 2. Those add together to get negative 2. Negative 2 multiplied by negative 2 is 4. Those add together to give me positive 4. Negative 2 multiplied by 4 is negative 8. Those add together to get me negative 8. Negative 2 multiplied by negative 8 is a positive 16. 16 comes down because I'm adding them. And then I have negative 2 multiplied by 16, and I get negative 32, and I have a remainder of 0. Oh, I'm so excited. Why? Because this tells me right here, I'm so excited, that x plus 2 is a factor of x to the 5th plus 32. So we found a factor. So that was kind of cool. If we take a look at our next example here, I'm going to do a negative 3 out front. I have 3, 5, negative 6, and 18. X to the 3rd, x squared, x, my constant. That was terrible. 3 drops. This negative 3 times that 3 gives me negative 9. Negative 9. Add those together and I get negative 4. Negative 3 multiplied by negative 4 is a positive 12. So negative 6 plus 12 is a positive 6. Negative 3 multiplied by 6 is a negative 18. That gives me 0. Remainder of 0. That tells me that x plus 3 is a factor of 3x to the 3rd plus 5x squared minus 6x plus 18. And in fact, my quotient here is going to be 3x squared minus 4x plus 6. Because my remainder is 0. Just like up here, my quotient is 1 degree less. So this would be x to the 4th minus 2x to the 3rd plus 4x squared minus 8x plus 16. So I found quotients, remainders were zeros on those two. This one says the complex conjugate theorem. According to the linear factorization theorem, a polynomial function will have the same number of factors as its degree. And if each factor will be in the form of x minus c, where c is a complex number. If the polynomial function has real coefficients and a complex zero in the a plus bi form, then a minus bi must also be a factor. So what is this telling me? Well, up until now, we've only really worried about real numbers, but I can have factorization. I can factor this into any polynomial into its linear factors, and sometimes I'm going to get complex numbers. So say I get down to x minus 2, and I had x squared minus or plus 16. It's not completely factored. This becomes x minus 2, and then the x plus 16 becomes x minus 8i, not 8i, 4i, x minus 4i, and x plus 4i. Now it's completely factored. So I have three factors. I have to have, if I have one complex number as a factor, which will produce the complex number as a zero, that means I have to have a complex number in the factors, and they have to be complex conjugates because I didn't start out with any coefficients on the original polynomial being complex. All right. The graph of the third degree polynomial is given. Use synthetic division to factor the polynomials into its linear factors. So I'm going to take, here's my factor, or here's my graph. Now I can tell you what one of my factors is because it's crossing right there. So remember from earlier videos, if I have a 0 at -1 or +1 comma 0, that tells me my factor must be x minus 1. So if that's my factor, I'm going to divide it into here. So using synthetic, I use the opposite sign, 1, 1, 2, and -4. 1 drops. 1 multiplied by 1 is 1. Those two add together give me 2. 1 multiplied by 2 is 2, and that's going to add here. This gives me 4, and then I end up with 4, and I get 0. 0. I don't know why it's not 0. Okay. So this is what I'm left with. I'm left with x squared plus 2x plus 4 multiplied by this x minus 1. This is not completely factored, right? Because this is not a linear factor. This is a quadratic. So I'm going to have to throw this into a quadratic. So I have negative b, which is -2, plus or minus the square root of b squared, which is 2 squared, minus 4. A is 1, c is 4, all divided by 2 multiplied by a. So this is the x's for this, not this part, but just this part, the quadratic part. So this is going to give me -2 plus or minus. Inside of here I have 4, and then I have minus 16. So I actually have -12 underneath the square root and 2. But -12, this is the same thing as -1 multiplied by 4 multiplied by 3. And it's the square root of it. So the negative square root of 1 is I. The square root of 4 is 2. And the square root of 3 is 3. So this becomes -2 plus or minus 2i, the square root of 3, all over 2, which becomes -1 plus or minus I, the square root of 3. So my factors, now I'm finally ready to do my factors. My factor is this, x minus 1. My second factor is x minus -1 plus I, the square root of 3. And then my last and final factor is x minus -1 minus I, the square root of 3. Now notice what I did was I pretty much wrote this entire thing, -1 plus and the -1 minus, and I did by default x minus. Now I can pull this negative through, so I can clean this up if I want to a little bit. X minus 1, x plus 1 minus I, the square root of 3, multiplied by x plus 1 plus I, the square root of 3. However, this is perfectly legit to leave it as your answer in that form. Okay, so let's do this one. I know that this is my my x-intercept, so that is 5, 0. That tells me my factor is x minus 5. So that is my starting x minus 5 is going to divide into that. So I have a 5 here. And I'm going to do synthetic, and I have 1, -4, -4, and 5. Actually, you know what? I'm going to move this slightly because that page number is kind of in the way. So I'm just going to go over here, and I'm going to do positive 5, 1, -4, -4, and -5. The 1 drops. 5 and 1 is 5. This gives me 1. This gives me 5. This gives me 1. This gives me 5. This gives me 0. So where I am right now is I have x minus 5. That comes from here. X squared plus x plus 1. That comes from here. Now I'm going to take the quadratic and factor that part. So just in that part, a is 1, b is 1, c is 1. So x is equal to -1 plus or minus the square root of b squared, which is 1 squared, minus 4 multiplied by a multiplied by c, all over 2 multiplied by a. So x is equal to -1 plus or minus the square root of negative square root of 3 all over 2. And the difference between this one and the previous one is I'm not going to get really nice values here. So this is going to be -1 plus and minus the square root of 3 multiplied by I all over 2. So now I'm ready to do my factorization. So the x, I started out with x minus 5. X minus -1/2 plus square root of 3 over 2i. And then x minus -1/2 minus the square root of 3 over 2i. Put it in the correct a plus bi form. Again, I can totally leave it like this, or if you feel like you want to pull this negative through, you can. I personally would leave it just like that. Here are some questions to ponder. If a polynomial of degree n is divided by a linear polynomial, what is the degree of the quotient? What if it's divided by a quadratic polynomial? So let's answer this part first. So if you have a polynomial of a degree n and you are dividing by linear, then this answer, your quotient, will have n minus 1 as the degree of that polynomial. However, if you're divided by a quadratic, then your quotient will have n minus 2 because you have dropped 2 powers and not just 1. If we consider k, x to the k minus 1 divided by x minus 1, where k is 1, 2, and 3, what would you expect the result to be if k equals 4? Well, we know that if we have x minus 1 over x minus 1, this is 1. This is when k is equal to 1. When k is equal to 2, I'm going to have x squared minus 1 over x minus 1, which is going to give me x minus 1, x plus 1 divided by x minus 1, which is going to give me just x plus 1. When k equals 3, well, this is just going to be x to the third minus 1 over x minus 1. Well, now let's actually do the long division. Up until now, I was able to factor. I could still factor this, but let's do the long division. So 1's going to go here. I have x to the third. Oh, here we go. My eraser wasn't working. I have x to the third. I have x squared. I have x. I have the constant. This will be 1, 0, 0, -1. So 1 will drop, 1, 1, negative 1, 0. That's a positive 1. So what I'm left with is x squared plus x plus 1. Now, what happens if you are now doing x to the 4th minus 1 over x plus x minus 1? See if you can do that one. And again, you want to consider this. What do you expect the result to be? Let you ponder that question as well. That's it for this video. Not too long compared to some of the ones that we do and will do. About 35 minutes in, not too bad. We'll see you in class if you have questions.